Hello, my name is Derek Yule, and I'm a solution architect with Amazon Web Services, based in Singapore. I'm here to talk to you today about deploying a hybrid IT environment using a combination of Amazon Web Services Cloud and your existing IT infrastructure. Pretty much every AWS customer has to go through what we're talking about today, but there are many different points of this journey that you can be at. Our focus is on a survey of tools to work with hybrid IT solutions on AWS. As this is considered a 200-level presentation, we're not going to dive deep or cover advanced topics, so experienced users of AWS may know some or most of this content already. If there's any parts where there's too much or too little information, please ask questions using the Q&A feature or go to the AWS booth in the exhibition area. There is no one-size-fits-all way that companies are approaching cloud adoption, but a common pattern we see with many larger companies starts with development and test workloads. Customers such as Lionsgate with SAP or the Tokyo Stock Exchange with Oracle have been running these for many years on AWS. Next is altogether new applications. There is really no rational reason not to do this, as these workloads have little to no legacy integrations to be concerned about. Next are digital, analytics, and mobile workloads. These represent new ways of presenting information to users and can usually operate on a different platform than the back-end applications. Customers such as Singapore Post, who deployed an all-new e-commerce website, and Qantas Airways, who deployed a mobile app for flight attendants to provide personalized service on airplanes, are running these workloads on AWS. Following this, there are business-critical apps. With recent significant pivots, such as the Monetary Authority of Singapore clarifying their support of the cloud, this has accelerated the pace of deploying sensitive workloads on AWS. However, this isn't new. Other companies such as Seco in Singapore and Archipelago International in Indonesia have been doing this for some time already. And then there's entire data center migrations, where customers make the big step of shutting down full data centers to save on operating expenditures. Here, Condé Nast shuttered their primary data center, and News Corp, in moving to AWS, reduced their number of data centers from 45 down to 6. Finally, we have all-in deployments, where all IT workloads for a particular customer are on AWS. There's an increasing number of companies here. Netflix was an early mover when it was still considered risky, but later they were joined by Dole, Suncorp, Nippon Express, Infor, and Splunk, who have all realized the benefits of a cloud-only model. Now, while we believe that in the fullness of time, the vast majority of companies will run almost all of their IT workloads in the cloud, it is today and always been a priority for us to make it easy for customers to run AWS as a seamless extension of their existing on-premises environment. So with this in mind, how do we define hybrid IT? If you think about it, pretty much any company that isn't all in on AWS is using AWS as part of a hybrid architecture. For our customers, this roadmap represents a common and structured approach for them to build their first workloads in the cloud. First, they start with building a strategy. You will need to know what you have, so review and evaluate what is in the current IT landscape. Note down all applications and tooling, infrastructure, integrations, and the end user's needs. Next, move on to the planning. What are you going to do when you deploy? This will lead you to building out your new or existing workload design for the cloud. Often, this means more than one application at a time, especially if they are linked. Then you build and migrate. Start with building out the core services on AWS. This includes the base infrastructure on AWS, connectivity to the cloud, and other key components, like an authentication and identity management infrastructure. Next, how do you get your data and applications into the cloud? If you are migrating something that exists, your approach is affected by the amount of the data to be transferred, the size of the network connection you have to AWS, and how much downtime you can afford for the application. Next, you have the run state, where you need to deal with operations. You should have some means of dealing with IT service management today. And although much of that can move with you, it's also important to consider that some changes may be necessary and important to help your organization optimize your use of the cloud. Going through this process takes some time if it is to be worth it, and requires some awareness of what we offer and the best practices approaches to building your type of solution on AWS. Fortunately, there's help through routes such as AWS training and certification, our tens of thousands of AWS partner network partners, and also through the team that we have online today. And there are also many services and features we offer today to help with this process. With the more than 90 services we offer today, I don't have enough space on this slide to show everything we offer to help you with this process, but here are the commonly used services. We'll spend the rest of the presentation going through these services and how they can help you with your journey to a hybrid IT deployment on AWS. Let's move forward to plan. Much of this step involves working with internal assets and information, but we do have some ways to help you with this process. For this, we offer the AWS Application Discovery Service. With this, you can discover and identify what you already have in your current IT estate, along with mapping out potentially complex application interdependencies, which are a critical part of managing the upcoming changes to your environment, and capturing application performance metrics. In the best case, all this is already done, but usually it isn't. And discovering this information is challenging when you need to do it at scale. Your inventory data is managed properly. It's transferred and stored in an encrypted form and can be easily exported for use with visualization tools or cloud migration solutions. The next step is build and migrate. First, we'll cover building out your core services on AWS, which creates a landing zone for you to build your applications on top of. We have quite a few services and features we can provide in this space, so let's run through some of the key ones. First step, when setting up most workloads on AWS, will be defining an Amazon Virtual Private Cloud, or VPC. This is a logically isolated section of the AWS cloud, where you can launch AWS resources in a network which you define based either on IP version 4 or version 6 addressing. You can define subnets, route tables, network address control lists, or ACLs, along with stateful firewalls called security groups to control access to your resources. This includes controlling what resources can access which networks, including the public internet or other external or AWS-based resources. Adding an internet gateway or virtual gateway allows you to enable this external connectivity. You can add network address translation resources, such as a NAT gateway, to selectively permit egress-only network traffic to the public internet. This can quickly grow to multiple VPCs, and there are documented approaches available from AWS on how to manage such a solution. But let's start with something based on a single VPC. Although it's possible to create the VPC and much of the rest of your core infrastructure through the web-accessible AWS console, or through the AWS command line interface, CLI, or the various AWS software development kits, SDKs, it's often more efficient to treat your infrastructure as code and deploy it through AWS CloudFormation. You can express your infrastructure configuration in a template, either JSON or YAML, and then apply it to easily deploy a full environment on AWS. And we offer a useful set of predefined templates known as AWS Quick Starts, which help you deploy popular solutions on AWS following best practices for high availability and scalability. This includes solutions from AWS and partners, such as Splunk Enterprise, Microsoft SharePoint Server, SAP HANA, Tableau Server, and many others. You can refer to the URL shown for more details. So let's select a scenario that's common in hybrid IT deployments. providing identity management through Microsoft Active Directory domain services. There are a few potential approaches to enabling Amazon Elastic Compute Cloud or EC2 instances to domain join with an Active Directory domain. You can do this either with an on-premise domain controller, an EC2 instance set up to be a domain controller, or through a managed service provided as part of AWS Directory Services, which provides a Microsoft Active Directory Enterprise Edition deployment in AWS. There are many advantages to the last option mentioned, as it is fully managed through AWS tools. So you don't need to log directly into the instance to configure it or to manage patching and updates. And in case you're wondering, yes, there's a quick start for that. You can use one of the tools we mentioned earlier. Let's assume it's the AWS console for now, to easily deploy this into your AWS environment. So now we have an infrastructure that has provisioned a managed environment for Microsoft AD, with 2 instances across 2 different availability zones for availability and business continuity. This can be fully managed through the AWS console. We have redundant instances of EC2 which function as a remote desktop gateway, so you can use Microsoft Remote Desktop or compatible means to log into VPC-based resources. And also 2 NAT gateways to selectively provide egress-only access to resources on the internet from VPC-based resources. This may be necessary for downloading patches or other updates, or sending metrics or logs. So now that we have a base environment, let's consider how to connect to AWS. You can, of course, access AWS over the internet, as you would already do for the AWS console or for public-facing applications based on AWS. However, for internal workloads, this may not be desirable. There are a few options to set up a private, secured connection to AWS. First is a virtual private network, or VPN, where you can establish links from your on-premise customer gateway using industry-standard IPsec encrypted tunnels over the internet. In AWS, you can link to a virtual gateway, which is provided as part of a VPC or to a software VPN server, which is a third-party software running on an EC2 instance. Our other option is AWS Direct Connect, where a service provider supplies a dedicated network link, such as a leased line or MPLS. This helps you isolate your traffic from other users and achieve a more predictable and selectable approach to network bandwidth, latency, and jitter. We have a strong partner ecosystem of APN Direct Connect partners who can provision the link for you and provide varying levels of configuration and support assistance based on your requirements. And full redundancy is possible through combining multiple links from the same or different suppliers, or even with a VPN as your backup link. Because a VPN is often the easiest starting point, let's walk through the logical steps of setting one up. First, let's establish the VGW, which is the AWS side of the link, along with the CGW, which can be a firewall appliance in the on-premise network. Next, we need to have some public IPs to use for the connection. The on-premise firewall has an address, as do each of the 2 tunnels that are being established from our VGW. After configuring the VGW, then taking the configuration file from there and using it to configure our CGW, we will have established the 2 tunnels, which make up our IPsec VPN. Once we've done this, along with a proper route table and security group configurations to allow traffic to flow through, we now have created a logical extension of our on-premise network to AWS. Because of this, if we are in our on-premise network already, we don't need to use the remote desktop gateway to access resources in our VPC, and vice versa. We can access them more directly from our existing network. So let's do a quick run through the steps you need to follow to set up a VPN to link the on-premise network to AWS. In this scenario, we will use a Palo Alto firewall as a CGW and a VGW for the AWS side of the connection. First, we need to create our VPN connection from the AWS side. From the AWS console, we create a VPN connection and we type in the name first. Let's use dev/vpc/vpn/con1. Next, we use the virtual private gateway that we created before. And we will define our CGW, or customer gateway here, which is our firewall or some other appliance representing the other side of the VPN in the customer's network. We'll type in the IP address of that firewall into the settings here. Then we will select a static route. Then we type in the CIDR range that will be routed through this VPN connection. Then click on Create. This will take some time, but eventually we'll create our VPN connection. Once this is done, there are now 2 tunnels defined with their respective IP addresses, which I will need to configure a connection to from my customer gateway. Both of them are currently showing as down as they are waiting for a connection from the CGW, as you can see here. What we'll do as a result of this is get a configuration file generated, which is specific to our CGW. This will show the detailed steps we need to configure our CGW. For this to work properly, we need to choose the correct appliance vendor, product, and software version, then click on Download. Notice that many different appliances are supported, and also various different appliance software types and versions are supported. Then we click on Download to get the file. Once we have the file open, we can see all the detailed steps we need to follow to configure the CGW. We start with the Internet Key Exchange, or IKE, crypto, and gateway, and then we do the same for the IPsec, tunnels, crypto, and gateway. This will allow us to fully configure our CGW. So let's take this configuration file that we downloaded for the Palo Alto firewall and use that to set up the configuration there. Type in the connection name first for the IKE crypto. There's a number of other configuration steps to follow, but as a detailed walkthrough of this is not the purpose of this demo, we'll just skim through that quickly and go to the end of the CGW configuration. This is all well documented, so we're not missing much. Eventually what we end up with is an IPsec tunnel. This will have been configured for the IP address of the tunnel 1 that we saw on the AWS side. In fact, we'll eventually have 2 tunnels created once we finish all of the configuration steps. Right now, the status shows as red, as it is not yet connected to the VPN in AWS. Let's skip ahead a bit until the configuration has been established. If we go back to the AWS side now, we can see that both tunnels are showing as up, because now the connection is established with the customer gateway. Switching back to the CGW, we'll notice that the status on both of these are green. And now with that, our VPN link has been established. Now that our VPN is up, we can start linking our on-premises resources more easily to AWS. The Active Directory is already configured from the Quick Start. Let's say we set it up as shown here, with a domain in AWS called fabricam.com, with 2 domain controllers, DC2 and DC3, as shown, with respective IP addresses and subnet CIDR ranges. We have an on-premise domain called contoso.com, with a domain controller DC1. There are on-premise servers that are domain joined with this domain, and all authentication traffic from these servers goes to the on-premise domain. So let's deploy an application in AWS, which the on-premise users will want to access. Then we can set up a trust relationship between fabricam.com and contoso.com, which will allow one domain to trust the users, groups, and resources in the other domain. This could be a 2-way relationship as shown here, but often customers will also go for a 1-way relationship where user data is maintained in the on-premise domain, and the AWS domain is just for resources such as EC2 instances. With this, if a user from contoso.com wants to access online applications and other resources, the authentication request just needs to go from the AWS-based application to fabricam.com, where it leverages upon the trust relationship to authenticate the user. Whatever permissions have been given to that user to access the resources will be resolved in that domain. So let's do a quick run through of the steps you need to follow to set up a trust relationship between an AWS-based domain and an on-premise domain using AWS Directory Services for Microsoft AD. So first we start in contoso.com. We need to configure the conditional forwarders in here, which will allow us to resolve host names in this other domain, fabricam.com. This is an important step to follow so that we can properly set up our trust relationship. So now let's flush our DNS cache. Then we can ping hosts in fabricam.com. Now, as you can see, we can reach hosts within that domain. Next, we need to configure our trust relationship from contoso.com. So we first start by typing in the name of the trust that we're creating. We select what type of trust. Then we also choose the direction of the trust. We will choose a two-way trust. Let's go through a few more steps where we will be defining the scope of the trust relationship. The outcome of this is we get to the trust password, which we will need to remember for when we create the other side of the trust relationship. For now, we won't confirm the outgoing trust as we've only created one side of it so far. So now we can see that the trust relationship has been established. Let's now switch to the AWS Directory Services console. From here, we can create our trust relationship from our previously configured domain in AWS, which is fabricam.com. First, we type in our on-premises domain name that we want to create the trust relationship with, which is contoso.com. Next, we will type in the password, which is the same as what we typed before. Then we select the direction of the trust, which is two-way as before. And for the same reasons as earlier, we need to configure a conditional forwarder. We'll need the IP address of a DNS server in contoso.com. Once we get that IP address, we can type it in, then click on Add. So now we've set up both sides of the trust relationship. There will be some amount of delay as the link is established between the two domains. We'll skip forward through the delay as it's not important for this demo. Eventually, the trust relationship will show as verified in the console. We can also see the details that we configured in the trust relationship wizard shown here. Let's go ahead and run a quick test then, where we'll have fabricam.com and contoso.com both side by side. So let's go to the Active Directory Users and Computers console. What we'll do first is create a group called Finance and a user named John within fabricam.com. Once the details are entered, we can see both of these are created in fabricam.com. Switching to contoso.com, we can see a previously created user named Kate and a group named HR Guys. So if our trust relationship is working properly, I should be able to take the HR Guys group in contoso.com and add the user John from fabricam.com into it. Let's add a user to the group, and we change the domain source to fabricam.com. Then we type in the username John. Now the fact that it can detect and add this user from a different domain into the group in this domain means that the trust relationship is working, and we've successfully concluded our setup. Now that we've set up the trust relationship, we'll also want to use this together with AWS Identity and Access Management, or IAM. IAM allows you to create policies to permit or deny access to actions or resources in AWS, such as creating, modifying, or deleting EC2 instances, VPNs, or running CloudFormation templates. We can permit users from the AD domain to log in and access resources in AWS through a link we created in AWS Directory Services. So this user in the Active Directory wants to create resources on AWS through the AWS console. We can have an IAM role assigned to that user previously, which will have a certain number of IAM policies tagged to it so that they can work with AWS resources. If the policies are set correctly, that user can then create a new subnet in the VPC and create an EC2 instance, which is configured for the subnet. Now that we have our landing zone defined, let's discuss services and features that help to migrate and validate your environment on AWS. Taking the environment we have already set up, let's check our options for loading data into AWS. This can be a database dump file, application binaries, or other file-based data. Let's first look at working with a core service, Amazon Simple Storage Service, or S3, which provides simple, durable, object-based storage, accessible as a web-based service. You can directly upload data into S3 using a variety of means, including the AWS console, AWS CLI, or even APN partner-provided tools. This is fast and efficient and delivers good performance on its own. Or you can set up an on-premise appliance, AWS Storage Gateway, which behaves as a network-attached storage device or virtual tape library. This can be easier to work with than when you can't change your method of transferring data, or it is already being stored to local or network-based storage on-premise. This will use a highly optimized transfer method to copy data into S3 or various other storage options in AWS. Another method, S3 Transfer Acceleration, uses our network of edge locations around the world and optimized network protocols, and can dramatically speed up copies into an S3 bucket, which is remote to the user from other parts of the world up to 5 times or more. And then there's also AWS Snowball, which is a petabyte scale data transfer solution that uses secure appliances to transfer large amounts of data into the cloud. After receiving the appliance, you can load your data into it, then ship it to AWS, who will load it into an S3 bucket or one of various other options. Another solution is AWS Import-Export Disk, which is similar to Snowball, but allows you to use your own disk storage devices to transfer the data. If you need to migrate running servers with minimal downtime, consider the AWS Server Migration Service, which simplifies the migration of thousands of live servers into AWS using tools to automate, schedule, and track incremental replications of live server volumes into AWS. This requires the AWS Server Migration Connector, which is a software appliance VM that you install in your on-premises virtualization environment. Once configured, data will be replicated as the server is running to the Server Migration Service, which creates an Amazon Machine Image, or AMI, which is a disk image. This AMI can be used to deploy new EC2 instances in AWS, which are a copy of what you have on-premise. For databases, a better option is the AWS Database Migration Service, which can be used to migrate databases into AWS with zero downtime. You can accomplish live migrations of live databases into AWS or use continuous data replication to implement high availability of databases. And together with the AWS Schema Conversion tool, this can be used to do heterogeneous database migrations. Let's take a source database and migrate that to AWS. A replication instance is deployed in an EC2 instance to pass the database data from source to target database. Finally, we move to the run step. Tying in and enhancing your existing runbook are a number of services from AWS that can help. There's an ongoing cycle of steps that should be undertaken while operating your hybrid IT workloads. The outcomes of each step feed into the next one. We'll start on infrastructure provisioning, which covers provisioning, configuring, and managing AWS infrastructure. We've already discussed CloudFormation and Quick Starts. AWS Marketplace is an easy way to procure software and services from APN partners. And the AWS Service Catalog helps you create a catalog of reusable solutions you can build for your teams to deploy. Next, we have configuration management with Amazon EC2 Systems Manager, which can automatically collect software inventory, apply OS patches, create system images, and configure Windows and Linux operating systems, either in AWS or on-premise. And then, monitoring and performance. With AWS CloudWatch, you can collect and track metrics and logs for AWS resources and applications, and automate reactions to alarm conditions. Next, we have governance and compliance. With a rich set of tools that track and react to changes in your environment, control and monitor access to your resources, build environments to your organization's standards, and test applications for compliance, you will have full visibility of your AWS environment for use in any audit or compliance scenarios. And now we have resource optimization with AWS Trusted Advisor, which helps you reduce cost, increase performance, and improve security by optimizing your AWS environment. And this brings us not to the end, but to another step in an ongoing cycle of operating your hybrid IT environment. This brings us back to the approach we introduced at the beginning of this presentation, and by now you should have a better idea of what is available to help you through this process. Take the time to learn more about the services and features that interest you the most through other sessions during AWS Innovate or the many other resources online, such as the AWS website, recordings of past AWS Summit or reInvent sessions on YouTube, or through classes delivered through our training and certification partners. Building a presentation such as this is never a one-person effort, and a significant amount of thanks go out to my many peers who helped me build this. And with that, we'd like to thank you all for attending this session. Before you leave, please fill out the feedback form so we can identify areas of interest or improvement.